Now, let's look at another method for calculating arithmetic mean. It's called the shortcut method. Okay. Like the simple way of calculating arithmetic mean, we did it for two types of data, raw data as well as for frequency data. Even the shortcut method, we can have a look at how we use the shortcut method for raw data as well as frequency data. Now, the shortcut method is generally preferred when you have to calculate arithmetic mean of large numbers. The example in the book is the numbers that you have is 305, 320, 332 and 350. When you have such large numbers, and especially in the days when the calculator was not so easily available, if you have to take its mean using the shortcut method, what you do is you select one of these numbers as the central variable. It's called the arbitrary origin. Arbitrary origin. This is also called the assumed mean. These are the two names that are generally used, the assumed mean, or it's called the arbitrary origin. Okay, and we are denoting it by A. So here's how you go about. Your numbers or your x values are big numbers, 305, 320, 332 and 350. So you can find D, which is distance of x from the assumed mean 320. So x minus 320. So 305 minus 320 is minus 15. 320 minus 320 is 0. 332 minus 320 is 12. And 350 minus 320 is 30. Alright. Now in the shortcut data, the formula for x bar is assumed mean A plus summation D divided by n, where summation D is the sum of deviation from the assumed mean and A is your assumed mean 320. A is your assumed mean 320. Summation D would be what comes here, the sum of D here. So that's 27. And n in this case is a number of observation, which is 4. So my x bar is 320 plus 27 divided by 4. As you can see, 27 divided by 4 is much easier to solve than a very big number. So 27 divided by 4, 4 6 are 24. That will be 6.75. So your final answer or the arithmetic mean of this raw data is 326.75. This same shortcut method can also be adopted for frequency data. So here the example is I've got weekly wages tabulated according to class interval. So remember, if you have class interval, it is the midpoint of the class interval that will be my x. So x in this case, 0 plus 10 by 2 is 5, 10 plus 20 is 30 divided by 2 is 15, 25, 35, 45, etc. So my x values are the midpoints of the class intervals. Now, how do you calculate deviation? Again, select one of the central numbers as your assumed mean or your arbitrary origin. Now if you have class interval data, your D or deviation from assumed mean should be, your D should be the value x minus the assumed mean divided by the class interval. That is value x minus the assumed mean divided by the class interval or the class size. So the class size here is 10. So over here x minus 25, which I've assumed to be my mean, divided by the class size is 10. If you don't know what your class size is, just do upper limit minus lower limit. Okay, you will get the size. So here it is 10. So let's see, 25 minus 5 by 10. Oh, so sorry. It's x minus, so it's 5 minus 25 divided by 10. So that's minus 20 by 10, which is minus 2. Similarly, 15 minus 25 by 10 will be minus 10 by 10, which is minus 1. 25 minus 25 by 10 is 0. 35 minus 25 by 10 is 10 by 10, 1. 45 minus 25 is 20 divided by 10 is 2. Right? And your f times d becomes much more simple to calculate. 3 times minus 2 is minus 6. 12 times minus 1 is minus 12. 20 times 0 is 0. 10 times 1 is 10. And 5 times 2 is also 10. So my summation fd is equal to just 2. Such a small number, right? And of course, summation f is 50. So in your shortcut method, the formula when you have frequency data would be x bar is equal to a plus summation fd divided by summation f, or capital N to denote the total number of observations, into the class size C. So A is 25 plus summation fd I can see is 2 divided by N, capital N is 50, into class size, which is 10. So that's 25 plus 0.4 or 25.4, which is the final answer. The examples that have been selected in these books have simple and small numbers. So you might not feel the advantage of using the shortcut method. But when you have very large numbers, I assure you that this method is much more useful, especially if you do not have a calculator.